Today we're going to be talking about covalent network, metallic, and ionic crystals. So the biggest, or rather prime example of a covalent network crystal is carbon when it forms a diamond. Carbon has 4 valence electrons, which means it always wants 4 more. So when it gets to bond with itself, it's really happy. So in the case of a diamond, carbon can bond 4 times to 4 other carbon atoms, like so. And then those 4 carbon atoms can bond 4 times to 4 carbon atoms also. 1, 2, 3. 1, 2, 3. So that is the structure of a diamond, and it just keeps going. It just keeps going. The formula for a diamond is CX. And this X right here in the subscript means that this extends indefinitely. So this right here is actually the strongest of all molecular bonds. So you can imagine that if the whole diamond is made up of this network of carbon, you're going to get an extremely strong, extremely high boiling point substance, which is exactly why diamond is so hard and strong, and it's so hard to boil diamond. So the next kind of crystal that I'm going to talk about is called an ionic crystal. Ionic. So I'm going to use the example of sodium chloride to explain the ionic crystal. Now, as you know, if you look on the periodic table, sodium has an extra electron that it's dying to lose, and chlorine has 7 electrons and it really wants one. So in the case of sodium chloride, sodium is going to donate an electron over to chlorine. Then chlorine will become negative, sodium will become positive, and all of a sudden they want to be near each other. So the structure of that is going to look something like this. You're going to have your positive sodium ions, and then you're going to have some negative chlorine atoms. And that's probably not exactly how it looks, but it's just showing that the positive sodium and the negative chlorine want to be really, really close to each other. So it's going to be a very strong bond with probably a very high melting point and probably really brittle. So for example, if you have like a block of table salt, not dissolved into water or anything, but just in a block, if you hit it with like a hammer or something, you'll see that a piece will fall off, and that's essentially just breaking this bond right here. So if I were to get a knife and just cut through the salt, it would just be breaking that bond right there, and that's essentially why it happens. So the next type of crystal is a metallic crystal. And as you know, metals like to get rid of, well, rather than get rid of, they like to share their electrons. So let's look at iron. In the case of iron, you have a bunch of iron atoms. These are all iron. And iron's electrons are pretty much just allowed to roam around the neighborhood. And yeah. And this creates sort of a sea of electrons, and they're negative, which makes it a very good conductor of electricity. And since the iron atoms have allowed their negative electrons to roam, they all become slightly positive. So depending on the type of metal, metallic crystals may be slightly harder than the ionic crystals. But that really depends on the case, because obviously we can name a lot of hard metals, but we can also name several soft metals, such as gold. If you take gold, 24 karat gold, and put a screwdriver on the top, if you try to dig the screwdriver into it, it will actually bend it. So the metallic crystal typically isn't as brittle as the ionic crystal. It will be a little bit softer. It'll kind of mold to what you want to do with it.